All right, we started to talk about this with processes or redirects. So every time you run a command, it creates a process for you. And every process has standard in, standard out. Standard in is your keyboard. Standard out is what's usually printed to your monitor. And standard in is usually directed to your monitor as well, but not always, depending on the case. So yeah, I think I asked the question. We have boxes with arrows. What do we do?
I'm at the end of the box, or end of the arrows.
Right. We connect all the arrows in boxes. What else would we do with them? The point here is that when you run a command, for example, if I were to do ls on dev, oh man, that's a lot of stuff. ls dev, when I hit enter, printed all that stuff out to standard out. If I wanted to hook up standard out and be standard in to another program, say more, I would do more, and now more is going to display everything, where every time I want to look at the next page, I hit space. And then I'm done. That way I can at least cycle through it. All right, so there's the word more. Another program is called less. And what happens here is instead of having to hit the space bar, you can actually scroll up and down from all the standard input. That way you can see what's going on. So let me show you what's going on. And when you're done, you hit Q. So with more, you have to hit space bar to go through it all. With less, you kind of have, you can scroll up and down. What does this tell you? So what's the relationship between less and more?
Less is more.
Yes. Actually, less is more than more, and more is less than less. Everyone got that?
Yeah.
Okay, good. Come on, guys, you gotta wake up. There's also the kill command, which is also hilarious. Well, I guess we'll get to that in a moment. Also, there's the kill all, which is also one of my favorite ones. We're kind of violent here sometimes. My favorite is it? Did they tell you what -9 is? Oh, they don't. Command kill. Send a signal to a process. Where's -9? Kill -9. Kill all processes you can kill. Whew.
So is that what like the task manager does? It just runs that command.
Yeah. Yeah.
It's just a good week for that command.
Maybe some people didn't like the fact that we were killing things. I don't know. All right. This can continue on. What data structure does this look like?
Q.
A queue. All right. So you can pipe it to another program with pipe, or you can dump it with less than or greater than sign. So let me show you. I'm going to show you the most useful thing for this class, because the rest doesn't really matter. If I do ls/dev, prints everything out from the dev directory. That's the device directory. These are actually listing all the devices on my machine. If I do greater than sign, think of it as like taking everything and pointing it to something, and then I give it a name, a file name list. I hit enter. It says, okay, well, wait a minute, what just happened? Well, if you do an ls, hey, we have this list file. We open it up. Oh, look, it's everything that ls just printed out. So if you want to save the output of something, you can dump it to a file by hitting the greater than sign. Got it? Huge benefit, or another thing to keep in mind, is that if you want to go back to a previous command, you can just hit the up arrow and that'll cycle through your history, and down, of course, goes forward in your history. Very helpful if you're trying to understand how or redo things that you are working on. There's a couple other things, cat, so forth and so on. The big thing is the double greater than sign. This attaches the text to the append. So when you do the regular greater than sign, it deletes the file essentially and overwrites it with the new information. When you do the double greater than, it opens the file and appends all the new information to the end of the file. So if you wanted to create a list from different commands, you'd want to use the append. If you want to just override and start from the beginning, the standard greater than sign. So for example, I can do echo hello, just prints out hello. If I dump, whoops, wrong way, dump it to list, it knows it didn't go out on my terminal. Open up list, I go to the end, there's hello, right there at the very end. On the other hand, echo hello with just one. When I open up a list, now it just has hello because it deleted everything. We're good? Yeah. That should be helpful at certain points. We talked about more, less, cat, tack. We did talk about cat and tack, right? Good. All right, printing. You're not going to be able to print. This capability doesn't work under Bash or Ubuntu under Linux, but we never really need to use it. Just keep in mind that there are some tools if you wish to print from the command line. LP prints the file, LPstat tells you about it. There's also LPR, which may be what you need to use depending on your operating system and your environment. It's not available here, but it's good to know. See, LPR. Password to change your password, manual pages, talked about that. Information pages, which is like manual pages, it's really manual version 2. We just called it info. And most commands except the dash help. So if the manual page isn't there, the info page isn't there, you can always do ls-help, and it'll try and tell you what it does. Notice it prints everything out. You will probably need to scroll up and down in order to view what's going on. Let me full size this window. Scroll up and down with this. I just do shift page up to go page up and down when I'm viewing things. Okay. Oh boy, regex. Wait, we did regex in OOP, didn't we?
Yeah.
Yes. Oh, good. Your regex commands apply to this terminal. Hopefully, that once you realize how powerful that statement is. Now all your regular expressions that you learned in Java are directly applicable here. Some examples. We can do ls-dev. Gives you a bunch of different guys, different information. But if we just want to do ls-dev, tty, and then anything after it, there's everything that starts with tty and has something afterwards. If you wanted to have /dev, tty, but only one character afterwards, we can use the question mark. And all your other regex commands are in here as well. I do invite you to at least learn some of them. Again, not required for this class, but will probably help you. Well, I take that back. You'll have to learn some of them for your homework, but afterwards, you won't need too much. All right, grep, global or get regular expression, and print. Yeah, you want to learn it. It's going to save you time. You have grep, fgrep, egrep. I always thought those were funny names. But you can print off different pieces of information. Probably what you're looking for is -n more than anything. So if we're in our class code, notes, all right, that's not, might not be too helpful. Let's go over to lab02, which has a source directory. If I do a lab source, let me look at all that stuff. If I want to do grep-n main on everything in here, it says, oh, it's in your main.cpp file, and the line 4, and the piece of code or the line is int space main, open close parentheses, curly bracket. So then you know, okay, if I want to edit this, I just go inside of main.cpp, and hey, look, there it is. We're going to go over this code in lab 2. I just wanted something in here to show you what's happening. Last thing that's helpful, if I were to do grep-n in this directory, let me see how well you've been paying attention. What do you believe the output would be?
just be main.cpp?
Okay, so we got one main CPP. Anyone else?
Yeah, I guess main.cpp.
All right, so what files are in this current directory? And the source directory. So if I were to run this command, will it see main.cpp? No. Sources directory. It actually tells you I can't search source. If you want to go into it, you do -r, which would recursively go into every directory and search it as well. And it says, oh, it's in source main.cpp. If you don't get anything from this, basically if you're running grep, -rn is what you're looking for. And you can put main in here. By the way, remember all those regular expressions? You can put those in the quotes as well. So even if it's MA, I don't remember how you spell main, but I remember it was 4 characters long. Or maybe it won't work here. Looks like it didn't work. Does the star work here? Interesting. You have to see why the double question mark didn't work. But a lot of the regular expressions do work.
These gotta be 3 characters long before it works or something.
Yeah, I don't know why the double question mark didn't work. There's a there's probably some yeah, because I think question mark means something else is the problem. I probably wanted this. Nope. I'd have to look that up. That's interesting. But the star worked. All right. There's a couple other lines that help you, but right now, -R in is probably what you're always looking for when you want to run grep. All right, we did some examples. All right, you can go through this example where we print cat all that info to a grep file, and then we can grep the. Actually, this is a great exercise. Let's do that. If I were to create a file that contains, well, you know it's your bedtime, new line, so turn off the light, comma, new line, say all your prayers, and then comma, new line, oh, you sleepy young heads dream of wonderful things, comma, new line, and you'll be swimming through the sea. If I were to type in grep the grep file, which the grep file contains up there, what would I get? Notice it's going to print off the line of everything it matches.
Line 3, then.
It would print off line 3, but before it printed off line 3, what else would it print off?
They say grep file, then line 3.
Oh, what would be the output if I were to run that first command? That's my question. Would it be all that? No.
It'd just be the, and then everything else after that.
It's going to, well, you know what? Let's go ahead and print this out. Whoa, that's not what I wanted. I'm going to make another directory called Linux commands. I'm going to move list into Linux commands. We'll move notes to Linux command. There we go. All right. So we'll do cat into grep file. Now I got to remember this line. Well, you know it's your bedtime, so turn off the light. All right. Well, you know it's your bedtime, so turn off the light. Say all your prayers. Oh, you sleepy young heads dream of wonderful things. All right. Oh, you sleepy young heads dream of, I already forgot it. Wonderful things. Wonderful things. And you'll be swimming through the sea. Control D to end it. Now if I were to cat grep file, it contains all that. So if I do grep the grep file, what do you think it's going to print out? We have the, we have the third line.
And then fifth line.
So you say third line and the fifth line. Okay, it is going to print the third line and the fifth line. You're missing one of these. What other lines are going to print out? Where you say your third line. Hit enter. I think we're saying, you might be meaning to say the right thing. So turn off the light, because it's the's in there. You'll be swimming through the sea. I think I missed something here.
Yeah.
And then, thank you. Oh, it didn't grab the from THE from then, because it was considered a holdable, or it did actually. There it is, and then. Wait, why didn't it get? So turn off the light and then. Oh, there it is. One moment, I think I typed something wrong. Say all your prayers then. Aha. Because it should grab then. There we go. Now that makes sense. So turn off the light, say all your prayers, and then, and you'll be swimming through the sea. Because THE was in each one of those lines. If you do -N, it tells you which line it's part of. What was it, -WN? The W means it has to be a word, so it would not match then because it's not the whole word. Get on that one? All right. And then what was the last one? Oh, V. That should just be verbose. What would that do? Invert match. Oh, so that's kind of funny. Find all the lines that don't have the or the inside of it. Everyone good? Can you see when if you had hundreds of files, that this would be useful? Oh. Uh-huh. Are you ever going to have that many files, Jonah?
Yes.
Okay, maybe not quite 100, but you are going to have a lot.
Like
you want
90.
you're going to want to learn this, guys. All right. Sure. grep.nd. What do you think that does?
Does that look for words that end in ND?
Close. Close. It looks for text that has ND preceded by any character. So it's some character and then ND. So, for example, your first one you have and. The next one, what do we got there?
Wonderful. Is that it?
Yeah, wonderful. Good job. Good catch. And of course, the last one you have and as well. Great catch. Now, this is kind of a weird one. This is saying the entire line must start with some character followed by ND. And. Yes, and is in the first one, but it doesn't start with that. Wonderful is in the second one, but it doesn't start with that. So, here, that's a good one too. I didn't think that would actually be anything in there. Yeah, that one doesn't exist. Wonder why he wrote that one in there. Maybe he meant this. I don't know what I was thinking of here. I would assume it'd be that. SL? This is SL followed by pretty much should be anything. Oh. I'm gonna have to get back to you why that one's behaving strangely. All right, grep a-d grep file. Find a line that has a capital A or a capital B or a capital C or a capital D, and print that one out. And then grep a.grep file. Basically A followed by something. Yeah, dot matches character. The solid brackets matches any character enclosed. The caret is the not. And this hopefully is a refresh. Star may follow any character that denotes 0 or more occurrences of the character that precedes it. Caret matches the beginning of a line only. And $ matches the end of a line only. Okay. Oh, this slide's old. Now that Bash is running on Windows, you don't have to worry about logging in, logging out, because that's managed by Windows now. If you virtualize it, keep in mind that there is logging in and logging out. After you log out, in general, you don't want to turn off the power, unless you need to. All right, sure. Really, the only thing cool here is time, which tells you how long a program took. So if I were to run sleep 1, ooh, yeah, take a guess. What did I just do? I'll run sleep 2 to give you a bigger hint.
Sleep for a couple of seconds.
Yeah, 1 second, 2 seconds. Why am I doing this? Time, sleep 1, took about a second. Can anyone guess why it wasn't exactly a second? This is actually very important.
But it had to stop it, right?
Yeah, I had to start and stop the sleep program, and that costs time. So there's the time of starting the program and stopping it, plus the program itself slept for a second. So keep that in mind. There's always a bunch of little things going on that can be hard to account for sometimes. All right, you can always halt and reboot. Run these commands if you really care to. No sync after rebooting. Basically, the idea with syncing is you want to make sure everything's flushed to the disk. Probably under Windows, you're used to, before you remove your USB flash drive, you need to make sure it's safe to remove. All that's doing is syncing all the contents that are meant to be written to the USB drive to there. In other words, when you write something to USB drive and the operating system says it's done, it's not actually done. It's just close enough to where you can continue on doing something else. So sync just says, all right, for reals, is it done? And then you can get out and complete. F forces the reboot. And you have your man pages as well. If we were under a true Linux system, we would have user administration. But since we're working under Bash, under Windows, Bash, under Ubuntu, under Windows, we don't have to care about usernames anymore because that's handled by Windows now. But do notice that Linux has user administration and has always had it for much longer than Windows. Well, I guess Windows always had one, but you add a user, you can modify different attributes, you can delete the user, you can change the passwords, you can change which shell, you can use a GUI to do it. I'm just going to run through this real fast. You have groups. Groups are basically, think of them as a role, as the easiest way I can think of it, is you might have a group for all your server administrators, you might have another group for all your standard users, or you might have a group for all the users of AH208, another group for AH203, another group for AH207, and maybe they have different permissions and different things they're allowed to access. Maybe you only want people in 208 to access that printer. You could set up a group so that only members of 208 can access that printer. That's just the idea, basic idea. User accounts, you can change them. Okay. RWX, read, write, execute. Remember on that ls-l, you had all those funny characters at the beginning and some dashes? That's what this is. Those are your actual permissions. So So if I were Linux commands ls-l rw, read and write. The first group is the owner of the file. In this case, West, me, can read and write to it. Everyone in the group, pwest, can read it, and then everyone else can read it as well. So if I were to do change, these values are given numbers. So reading is 4, writing is 2, x is 1. So the point here is if it has a 0, it has no permissions. If it has a 4, that means you can read it. If you have a 5, you can read and execute. See, it's 4 plus 1 equals 5. Ah. 6, you can read and write, but you can't execute it. And then 7 is full permissions. To give you an example, if I were to chmod 000 on notes, and then I try and cat notes, permission denied. Change mod, change modification. I'll change it back to 400 on notes. Now I can cat notes, and it does it for me. Since I was the owner of the file, I was allowed to change the permissions. Someone else owned the file, they could change the permissions, but you would not be able to unless you are root. Root's allowed to do whatever he wants. So what does chmod 777 on notes do?
Full permission for everybody.
Full permission for owner, group, and everyone else. Let's see. How to ask this question. Should you be doing this?
No.
No. Will this fix all your permission issues? Yes.
Yes, it will.
If you're just going nuts, banging your head against the wall, getting permission denied, go ahead and do this. It's bad practice, but every once in a while, I've had my moments where I'll just do chmod-r777 star. What does that mean? What was the R doing earlier?
Recursive, correct?
Yeah,
So
recursively
every
go to,
file.
yes. So this means go to every file, give it full permission to do anything.
In your entire system?
Oh, if you wanted to do that,
Oh.
you would
That's
that.
that means we can get it.
Yeah, everyone has full control over everything.
Just go to root and delete all
Don't do
your
this
files.
unless you really are dire, okay? But I just wanted to show you, every once in a while, you gotta do it. All right. Okay, some examples. Read, write, execute for the owner. Read and execute for the group. Read and execute for everyone else. Chmod 754. 7 means read, write, execute. 5 means read, execute, so read and execute. And 4 means just to read. So notice that they changed that X to taking off execute from this archive.sh. What's this one saying? I've said it a couple times. What are these symbols right here in front of top secret mean? The owner can, the group can, and everyone else can. After we chmod 600, the owner can, right, the group can, nothing, and the everyone else, nothing.
It's top secret.
Obviously. And this, of course, is perfect security. It helps. It's definitely, there's many other things that need to happen, but this is at least a start to understanding security. All right, here we go. What do we have here? Someone just read it out for me.
Read, write.
For
The user, the admin.
owner, owner of the file. And then
Next result.
nothing for the group, nothing for everyone else. Chmod to 665, now the owner.
Read, write.
Mhm.
Read, write.
And everyone can read it. It's very common for everyone to just be able to either read or not read, or read and execute. It's usually a very poor design decision to let everyone write to a file, just FYI. Passwords. There's a password file under Linux.
I think there was a typo on that.
On this one from last time?
On the previous slide, should it be 664?
You are correct.
Yeah, 665 would be he could read and execute.
Nice, so you are paying attention.
Yeah.
Yeah. Good catch. I totally did that intentionally.
Uh-huh. Nice one.
Yeah, you saw that? That was
These
good.
book slides? That book.
All right, good catch. Good catch. Okay, Etsy passwords where your, well, it's actually user information. Originally, it's where your password first stored, and then they decided it was a bad idea to store passwords in a file that people could read. Minor things. But if you read this, the first thing is the user, SSD. The next thing is your password. You see it as an X. The password is not X. That actually just means you need to go look at a shadow password file to find your actual password. The next two numbers are your user ID, 74, your group ID, 74, and then some more information. If you really want to look into it, you can. The big thing to keep in mind is this where your username, your password, your user ID, your group ID is stored. This is what you're known as. So if I had mine, it'd probably call it Paul West, home directory where it's located, and then shell. Let's go ahead and do that. Grep West from Etsy password. Quest X is not my password, guys. My user ID is 1000, group ID is 1000. This is the name it knows me as. A lot of times the rest of it's unimportant, no one cares. But my home directory, aka where I store my files, normally is HomeQuest, and my default shell is bash. There are other shells. There's bash, CSH, ZSH. There's also ash and just BSH. By the way, BSH was called Bourne shell, and then BASH was called the Bourne again shell. All right, and you list all the other usernames if you want to look into it. Becoming root, SU-root, you have to put in the root password in order to do this, and then you become root. For example, if I were to try and cat Etsy shadow, permission denied, but if I were to become root, and we were to cat Etsy shadow, please don't break into my system after I do this. And now actually, this is actually my password. Okay, it's not. It's actually the SHA-5112 hash with the salt over there, my password. Now anyone online that's watching this video can try and crack it. Good luck.
It's Steve, isn't it?
It's 1, 2, 3, 4. That's what it is.
It's password.
Password.
It's Shiloh 1, 2, 3, 4.
Ooh, that's a good idea.
Crap, that was really close.
Whew, that was fast.
Yeah.
Woo!
Sweat on my brow.
All right, login prompts to the username. I would show you what this is, except for by going into the standard terminal, I lose the ability to record my screen. So I'm not going to do that. But if you were, it just comes up and asks for your username, and then you put in your password, and now you have a terminal. I think I explained most of this already. TTY. Anyone want to take a guess on what TTY stands for?
Talk to you later.
Oh, that was good. What, talk to you.
Tell us something.
Tella, we're good. That's right. The first one's Tella. All right, what? Think past. Think a long time ago, before you had monitors, how would we print something?
Oh, is it a teletypewriter?
Yes, it's a teletypewriter. No joke. That's what it means. You got to remember, way back in the day, before even I was born. I know,
Print
man.
out cards, right?
Yeah, they had cards, and they would print it with a typewriter. But instead of it being a manual typewriter, it would be a teletypewriter, electronic typewriter. So it was called TTY because you want to print all your output to the teletypewriter. Being Unix, that's how everything was in the beginning. We still just call it TTY because, in all technicality, your monitor is a teletypewriter. That is what it is. It's just a very advanced form of it. Hopefully, y'all can see that. But yeah, user TTY is where you're going on. You got TTY 0 through 7 normally, and you're going to have a bunch of other TTYs. If you ever see TTY with a capital S, that's your teletypewriter going over a serial connection. You can also do TTY USB. That's your teletypewriter going over a USB connection. But notice how teletypewriter, early 70s, teletypewriter, your monitor, it still works. They didn't have to reinvent something. They just basically appended it to make it happen. They didn't have to rewrite the operating system and come up with a new version of Windows. Just a side. Quota. I don't think I gave you a quota, so congratulations, you can fill up the hard drive. But a quota is just basically how much space you're allowed to use on your system. All right, now to lab 1. Any questions over what we went through? Everyone's got it perfectly memorized, and everything's down. You're masters at grep. You know how
I'll
to.
watch the video like 2 or 3 times tonight.
What?
I'll probably watch the video like 2 or 3 times tonight.
That'll be good. Yeah, the homework will help a lot to solidify this. All right, so let me